if I'm given the equation for two spheres, how can I find the distance between them, and then how can I find how close they are from touching? Let's start by writing the general equation of a sphere. It would look something like this. X minus x1 squared, y minus y1 squared, plus z minus z1 squared equal to r squared, where r is the radius. Now, this general equation of a sphere tells me that the center of this general sphere is x1, y1, z1. Now that I have all that down, I can get a lot of information out of the equations for sphere 1 and sphere 2. Let's start by looking at sphere 1. I can tell that if I were to write this in the general form, general equation of a sphere, I'll know that the center is at the origin, because it would be something like x minus 0 squared plus y minus 0 squared plus z minus 0 squared equal to the square root of 1, which is just 1. So, yeah, the center of sphere 1 is just the origin. But in sphere 2, I can tell that it is not at the origin. The center is at 2, 6, 3. Now that I have the two centers of the spheres, I can find the distance between the two. And the way I find the distance between the centers of two spheres is just like finding the distance between 2 points. And the way I find the distance between 2 points is using the distance formula. So that would be x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Now, what's really nice about this problem is that sphere 1 is centered at the origin, so I just need to compute the center of sphere 2. So that would be 2 squared plus 6 squared plus 3 squared, which is 4 plus 36 plus 9. Square root of 49 is just 7. And so I know that the distance between the two spheres are 7 arbitrary units of distance. So that answers the first part of the question. Now, how do I tell how close they are from touching? Meaning, just looking at the outermost edge of the spheres, I am looking at this distance, the gap between the two, not the centers. So how do I find that? Well, if the distance that I just computed was from the two centers of the sphere, and I'm trying to find the gap between the two edges of the spheres, then I need to account for these two distances over here. In sphere 1, if I'm looking at the distance from its center to its outer edge, that corresponds to its radius, which I will call r1. And then in sphere 2, similarly, if I'm looking at its center to its outermost edge, then again I'm looking at its radius, which I will call r2. So let me draw that line down here. Same line that I drew up there, but just to see it more clearly. This whole thing is the distance, d. That is d. And I'm just trying to find this little piece over here. Let's call it whatever, t. And this distance over here is going to be r1. And then this distance over here, this distance over here is r2. I could use different colors. Okay. So what would t be if I have the entire distance and then I have r1 and r2? Well, that little piece t is the whole distance d minus that little piece here, which is r1, and the other little piece, r2. And now I already have all of this information. D is the distance between the 2 points, which I had just found, so that's 7. And then r1, which I can get from the equation of sphere 1, is the square root of 1, as I said, which is just 1. So R1 is 1. And then R2 is the square root of 16, which is 4. So then the distance between the two spheres touching is just 7 minus 1 plus 4, or 7 minus 5, which is just 2. And that's it.